Greetings and welcome to A Plus Academy. Today I just want to explain on one of the techniques that we use for trigonometric integration. So I'm going to pay attention to this one example that we have here, which is the integral of 1 over 1 minus x squared dx. And the standard integration is arc sine x plus c. So it's very important to know these standard integrals of specific functions. But let's just jump straight into one of the questions that we have. So we are required here to find the integral of 1 over root of -5 plus 6x minus x squared in terms of x. So if you look at this particular question, you will find that it takes the format of this basic integration problem. So what we are going to do is to manipulate this expression under the root sign so that it takes that particular format under this root sign. One way of doing that is by completing the square. So we are going to use the method of completing the square. Completing the square. Now in this case, we are going to focus on the -5 plus 6x minus x squared. Now to do this, we'll consider these two terms here, which form a quadratic expression. So we have -5, we keep that one, and we are going to complete the square on this section, which is this part of the quadratic expression. Now we prefer that we take the leading term, which is -x, to be positive. So one way that we can do that is to factor out a negative term. So when we factor out negative term, -1, we are going to get -6x plus x squared, which we can write as -5 in minus x squared minus 6x. And here we are going to add a term that will make this expression a quadratic term. And to do that, as we may know, we have to add half the coefficient of x, which in this case -6. So we're going to have x squared minus 6x. So we are going to add a term here, which is the square of half of -6. So half of -6 is -3. When we square that, we are going to get a 9. Okay, but if you look at this closely, we are actually subtracting a 9 because we have got a negative outside that will multiply here. So we are subtracting a 9. So to avoid our original equation changing or being different from the original one, we do add a 9. So we've got a -9 plus 9, which is actually 0, which translates to the fact that we have not changed our expression. And now if we evaluate this one, this is going to be -5 plus 9, we'll get a 4. And then this part here is the one that we can factorize, which will give us x minus 3, which is x minus 3 squared. So we have completed the square in this particular part. So we now have a square term. Now, so which means that coming back to our problem, this integration problem, the integral of 1 over a root of -5x. This term here, -5 plus, it has been transformed into that expression. So we can write this as the integral of 1 over, just read it again here, -5 plus 6x minus x squared dx. It will be equal to the integral of 1 over the root of this, okay, which is a 4 minus x minus 3 squared. We are integrating with respect to x. This will give us the integral of, now if we compare this with our standard case problem here, we have got the integral of root of 1. So we need to create a 1 here. So we do that by substituting, factorizing a 4 out. So we will have, take out a 4 out, we have 1 minus, and this term here, x minus 3 squared, it will be divided by a 4. And we are deriving this with respect to x. Okay, simplify this further. It will give us a 1 over, take out the 4, we are looking at a square root of 4, which is a 2. So we have a 2 into a 1 minus x minus 3. Now this one, we can combine, we can write this as a square of one term, which is x minus 3 over a 2, okay, squared. Now, which we can factor out the constant half, which is a half into the integral of that. Okay. Now what we need to do here is to change this, one, replace this term with one letter. Okay, any variable that we can use, we commonly use a u. So we can say let u is equal to x minus 3 over 2. Okay, and differentiating this one, we have got du dx is equal to, this one will be equal to a half, which means that we are going to have our dx being equal to 2 by du. Right, the intention here is to substitute this symbol here, dx, with a 2 du. So when we do that, we are going to have our problem as 1 over root of 1 minus this x minus 3. We now substitute it with a u, so it will be a u squared, and into our dx is a 2 du. Okay, you realize that these two, they will divide and cancel out, so eventually have our integral as 1 over root of 1 minus u squared du. So we have reached this particular format now that we wanted over here. The only difference is that here we have got an x, and in our final simplification we now have a u. So this simply translates to arc sine, which we write as that u plus a c. But now our problem is in terms of x, so we know that, but our u, as we have given here, is an x minus 3 over 2. So we substitute this with that case. So eventually we are going to have our answer, writing the whole problem here, plus 6x minus x squared dx being equal to arc sine, okay, u, which is x minus 3 over 2 plus c. So that solves our problem.